about type 1 and type 2 errors and the power of a test. So as we learned before, type 1 and type 2 errors happen when we either reject a true null hypothesis, that's a type 1 error, or we fail to reject a null hypothesis when it is actually false, and that is a type 2 error. So if you remember, we have this little box to kind of organize this. If my null hypothesis is indeed true, but I reject it, that's a type 1 error. If I fail to reject it, that's actually a correct decision. Happy face. If my null hypothesis is false, and I reject the null hypothesis, that's a correct decision. If my null hypothesis is false and I fail to reject it, that's called type 2 error. So when you're looking for these types of errors, if you can recreate this organizer, that will help you decide what type of error, if at all, it is. Okay, so what consequences do we have for different types of errors? So it really depends on the situation, and a lot of times statisticians will do kind of pre-studies to decide which situation would be worse and make the study so they avoid the error type that would be the biggest problem for the situation. So here's an example. So Jamal owns an auto parts store. Every week a truck delivers a large shipment of brake rotors to his shop. He will only accept the shipment if less than or equal to 9% of the rotors are rusty. If there are more than 9% that are rusty, he sends the shipment back to the manufacturer. He does not have time to investigate the whole shipment, so he takes a random sample of 100 rotors and uses these hypotheses. So H naught is that the proportion of rusty rotors is 9%, and HA is that the proportion of rusty rotors is greater than 9%. So let's look at our chart and see what that would mean. So if H naught is true, in other words, the amount of rusty rotors or the proportion of rusty rotors is equal to 9% or less, and I reject that, that is going to be a type 1 error. And that means that Jamal will send back the truck or send back the shipment even though the shipment is good. So he sends back a good shipment. Which will mean that he will have less things to sell on his shelf and less product and probably less money coming in. If he fails to reject H naught, that's actually a correct decision. So that's good. All right, so what about the other situation? So what if H naught is actually false? So that means that HA is true and we reject H naught. So that's a good scenario. That's a correct decision. But if H naught is actually false and I fail to reject it, that's a type 2 error. So what would happen if a type 2 error occurred? So if H naught was actually false, but I fail to reject it, that means that my shipment has more than 9% of rusty rotors, but I still accept the shipment. So I still accept a bad shipment. So what will happen to Jamal's shop? He'll have a bunch of rusty rotors on the shelf, and customers might buy them and blast him on Yelp, or he realizes they're rusty and doesn't have enough product to sell. So you as a statistician have to decide which of those types of errors are worse repercussion-wise and which ones to avoid the most. Okay, you can't avoid both of them at the same time, because what we realize on the next section is that if the probability of a type 1 error increases, the probability of a type 2 error decreases. So, in any given test, the probability of a type 1 error occurring is equal to the alpha level. So you want to consider the consequences of a type 1 error before choosing the alpha level of a test. And the power, so this is a new vocab word, so the power of a test is the probability that the test will reject H naught if H naught is false. So a more powerful test will be more likely to reject a false null hypothesis. And power is equal to 1 minus the probability of having a type 2 error. Okay. Calculating the power is very convoluted, and you won't have to do that, but you do need to know how to increase power. We'll talk about that in a second. All right, so the probability of a type 1 error actually decreases when the probability of a type 2 error increases, and vice versa. So if you do some things as a statistician to decrease your type 1 error, you have to be wary that that's going to increase my type 2 error, and vice versa. One way to decrease type 1 error, actually the only way to decrease type 1 error, is to just increase your alpha level. Because the probability of a type 1 error occurring is actually equal to your alpha level. If you increase the alpha level, then you will decrease that probability of that happening. Okay. So to decrease a type 2 error and increase the power of a test has actually a few ways you can do it. The first way is to decrease your alpha level. And the second way is to increase your sample size. And increasing the sample size is almost always a good idea. You have to watch for your independence check when you're doing that, but increasing the sample size is usually a good idea in most studies anyway. So if it's plausible to increase the sample size, you should do that. Another way to do it is to just improve your sampling process in general. So if you didn't have a good way to sample, if, for instance, stratifying instead might be better, then you should do that to improve your sampling process. So statisticians must do some of this work ahead of time to minimize the consequences of the worst type of error for this situation. And I know it was yesterday, but I didn't get to see you guys, so I want to wish you a happy belated